U.S. Geological Survey, why are the earthquake and volcano people at a pollinator conference? We are so much more complex. I'm Elizabeth Sellers. I'm with the U.S. Geological Survey. I am a collections and taxonomic data development specialist, and my focus area is on pollinating species and making the data for pollinating species more widely available for the kind of research that you're seeing presented here. It's my great pleasure to present to you Dr. Clint Otto, or introduce him to you. He is a research ecologist with USGS. He's stationed at our Northern Prairie Wildlife Research Center in Jamestown, North Dakota. And since 2014, he's been investigating the impact of land use change on pollinators and ecosystem services in the Northern Great Plains region. Much of his research focuses on the development of decision support tools to inform natural resource management and policy. So please welcome Clint.
Thanks, Liz. And greetings to all of you from North Dakota, the land of summer honey and winter chill. I had to survive a blizzard to get here, my first NAPPC meeting. So we're through one blizzard and we probably only have a dozen more to go. So today I'm going to present to you some of my team's research that we've been doing since 2015, where we've been looking at land use and land use change in North Dakota and the Northern Great Plains and how it affects pollinator health and pollination services. So before I get into the research, I'd like to thank all of my co-authors listed here. All right, May and Diana already gave an excellent overview about biodiversity declines and insect declines, so I won't belabor that point. I'll only mention for our native bees, our nation lacks a monitoring program for our 4,000 plus native bee species. So we have no real way of gauging long-term population trends for a vast majority of our native bee species. And of course, we know about the importance of pollinators for the services they provide to us humans. $15 billion a year in ecosystem service. The lion's share of that ecosystem service goes to the honeybees for pollinating agricultural crops, and that's what I'm going to talk primarily about today. But a lot of the work that we're doing on land use change applies to native bees as well. What you may not be aware of, where I live in the Northern Great Plains, every summer about 40% of our nation's honeybee colonies are trucked across the country to the Northern Great Plains. Beekeepers have been bringing their bees to the Northern Great Plains for multiple generations, not only to make a really valuable honey crop, but also to bolster the health of their colonies so that those colonies are alive and well. They survive the overwintering period and can be trucked across the country to provide that much needed pollination service. We don't have great baseline estimates on our native bee populations there or distribution, but based on expert opinion, there's about 250 native bee species in the Northern Great Plains, maybe 300, and also the core range of the eastern population of monarch butterflies. So I submit to you, achieving some of our nation's pollinator health goals goes hand in hand with having great forage and great habitat in the Northern Great Plains. And land management activities that are provisioned within the U.S. Farm Bill have a profound impact on pollinator forage in the Northern Great Plains. Today for my presentation, I'm going to focus on one sort of conservation program, the Conservation Reserve Program, or CRP for short. Many of you are probably familiar with CRP, some of you aren't, so I'll just mention this is a federally funded program that's administered by the U.S. Department of Agriculture. It's voluntary. It targets private landowners where a landowner can take their environmentally sensitive cropland out of crop production and put down some sort of conservation cover. And where I live in the Northern Great Plains, typically that's a grassland. A lot of CRP is in the form of a grassland. There's about 24 million acres of CRP nationally, and there's a deep body of literature touting the benefits, the ecosystem services that CRP not only provides to landowners, but also to the American taxpayer, the rest of society. And most recently, there's been some work coming out looking at the benefits of CRP to bees. So on these CRP grasslands, you have a lot of flowering plants, and I'll show you a picture of a CRP field in a little bit, but a lot of flowering plants, and of course that's providing the pollen and nectar resources that bees and other pollinators need to complete their life cycle. So to be fair, most of this research listed here is focused primarily on honeybees, but I know nationally there's active research being done on looking at the benefits of CRP to native bees as well. My team's part of some of that research, but I know there's a lot of independent researchers out there looking at the value of CRP to native bees. So with that background in mind, here are my team's research goals over the past few years. This is what we've been primarily investigating. First, we want to quantify historic CRP trends around apiaries in the northern Great Plains. For those of you who haven't heard that term, apiary, that's just a place on a landscape where a beekeeper chooses to put his or her honeybees, put them out to pasture for the summer, basically. And so we want to look at trends in CRP area around these apiaries in the northern Great Plains, because we know it provides forage for bees. And then secondly, we wanted to forecast the effect of future CRP acreage caps on supporting managed honeybees. So here we want to peer into a crystal ball, so to speak, to look and forecast the effect of future land use changes as provisioned by the Farm Bill, and how that's going to affect landscape suitability for supporting managed honeybee colonies. And it has direct application, we believe, to some native bee groups as well. And then finally, we want to understand how land use in the northern Great Plains affects honeybee health and pollination services elsewhere in the country. So this is the idea of what some ecologists and economists call spatial subsidies, where land use in one part of the country is subsidizing an ecosystem service that's ultimately provided in another part. So we're going to follow North Dakota bees to the almond orchards of California and look at the linkage between land use and pollination services. All right, to tackle that first question about, or the first goal about CRP trends through time, this is a pretty straightforward approach, and it's all boring computer modeling stuff, so I'll spare you the details on what we did. But we obtained apiary locational data from the State Department of Agriculture in North and South Dakota, two of the top honey-producing states in the entire U.S. And so we have those locations noted in red where beekeepers choose to put their honeybee colonies. And then we just brought these into a geographic information system, and we used a bunch of land cover layers to model changes through time in various land covers. And we've already published on changes in corn and soybean acreage, wetlands, grasslands, and so forth. And what I want to share with you today is the changes in CRP, the Conservation Reserve Program. And this is the results slide for that analysis. So here we're looking at gains and losses in CRP area around these registered apiary points. The heat map that you see, anything in red, orange, or yellow, that's where CRP is declining, decreasing around apiary points. So see, the CRP is important, of course, for providing forage for bees. That's why beekeepers are putting their bees to pasture out in CRP fields or in close proximity to CRP. So anything in red, orange, or yellow, CRP is decreasing. You got to look real hard for dark green where we actually see a sizable amount of CRP increasing, like maybe that spot here, and there's a little bit over there. But on average, we estimated in 2006 there was about 76 hectares of CRP per apiary in the Dakotas. And by 2016, that value was cut to in more than half, down to 36 hectares per apiary. And what's more, if you look at those numbers in the county boundaries, that's the relative density of apiaries per county. It's actually the number of apiaries per 40 square miles within that county. So we can see right here, if you can see that pointer, this is kind of like the core zone for beekeeping. Probably the highest density of apiaries in the entire country, with the exception of California during almond pollination. Perhaps even the entire world, I don't know. But that's where we're seeing all this CRP disappearing, it's decreasing. As a wildlife biologist, I'm a trained wildlife biologist, I would say we're losing habitat in the core population zone of our wildlife species of interest, if we apply that logic to our honeybees. And here's a picture of a CRP field right here, by the way, so you can see all the flowers out there. So if we're losing CRP, what is it being replaced with? to answer that question, we did a conversion analysis. And we looked at CRP, and we estimated that about 243,000 hectares of CRP was converted to row crop and crop for multiple years just in North and South Dakota over this 8-year period. If you need a handle, what does 243,000 hectares look like? That's about 3/4 of the size of the state of Rhode Island, just in 2 states here, over 8 years. So a lot of conversion. About 65% of the converted CRP was first cropped as corn or soybeans. So yeah, we were applying a honeybee focus to this analysis, but this is forage for our native bees and forage for monarch butterflies as well. If you want to see what, just an aerial view of what converted CRP looks like, here's a CRP field in 2011. A beekeeper is elected to put their honeybee colonies out here. You can see where they drive their truck in, right in the grassland, turn around, dump off their honeybee colonies. And if we flash forward to 2017, we see that that CRP field has been converted. It's no longer a grassland, it's been planted in some row crop. And as a consequence, that beekeeper has vacated the site. Now, I don't have any empirical evidence to share with you, but I go to a lot of beekeeper meetings and I hear them talk about how they're being forced in tighter and tighter areas, competing against other beekeepers for dwindling forage grounds. As an ecologist, I'm really interested, what does that do in terms of intra-specific competition, that is honeybees competing with other honeybees for forage and decreasing potential honey production, but also interspecific competition. With all these honeybees being trucked to this region and not having a decrease in forage, what is that doing to competition with our native bee species as well? Those are interesting questions to ask in the Northern Great Plains. All right, so our trend analysis in CRP mirrors that of what is going on nationally. And I don't expect you to be able to see all this on the graphic, but that green line that I want you to follow, that is just the national trend in CRP. It capped out about 2007, 2008, and it's been declining ever since. And of course, the future of the CRP is always decided upon by the Farm Bill that Congress votes on every 5 years or so. And there's a considerable amount of stakeholder involvement in deciding that national cap. Some stakeholders want to see the CRP cap, the national cap, the acreage cap raised. Others want to see it stay the same, and others would like to see it go down. So when we started this analysis back in 2016, 2017, there were 3 main caps that were being debated upon by various stakeholder groups. 37 million acres nationally, 24 million acres nationally, and 19 million acres. Now, ultimately, Congress that just passed a farm bill back in 2018, they decided upon 27 million acres to be implemented by 2023, I believe. But so the caps we evaluated in our scenario modeling ultimately is not what Congress decided upon, but nonetheless, we were kind of in the ballpark. And what we ended up doing, we took these national caps, these hypothetical caps, and then we redistributed and created a landscape in a computer model, created a landscape and redistributed CRP on this hypothetical landscape. And we distributed CRP based on these 3 caps that could be potentially implemented. And then based on the new distribution of CRP, we could take estimates from the published literature that tell us essentially how much forage bees require to either achieve high annual survival rates or how much grassland beekeepers want to see out on the landscape before they select a site to be used as an apiary. We could take those data, the published estimates, and ask which apiaries in North and South Dakota meet some of the key forage requirements based on the published literature, just based on the existence of CRP alone. And so when we did that, here are some of those results we had. So if we have a 2018 baseline where we assume 24 million acres of CRP nationally, we estimated that about 3,000 apiaries in North and South Dakota met the key forage criteria just based on the existence of CRP alone. If the national cap got adjusted to 19 million acres, we estimated that that would decrease the number of apiaries that met those key forage criteria by about 28%. And here's kind of where the losers, if you will, would occur, where those apiaries that under a 24 million acre cap met the key forage criteria, but under a 19 million acre cap no longer met those criteria. On the other hand, if the cap was increased to 37 million acres, we estimated that would increase the number of apiaries that met those key forage criteria by about 155%. And here's where the winners would play out, essentially based on our scenario modeling. Those are all the new apiaries that didn't meet the forage cap, or didn't meet the forage criteria under 24 million acres, now met it under 37 million acres. All right, and just to wrap things up in the last portion of my talk, I want to present my team's data on how we conducted a field study looking at how land use in the Northern Great Plains affects bee health and colony size and the pollination services they provide elsewhere in the country. So to do this field project, we partnered with a bunch of commercial beekeepers across 3 states, both Dakotas and Minnesota. And we wanted to select bee yard or apiary locations across a land use gradient. So we had a land use gradient going from grassland to row crop agriculture. And this is just an example here of some of our apiary locations in North Dakota. I have one here, if we have an apiary right in the middle, that's a site that's surrounded mostly by grassland. And we hypothesized that bees would do better in sites with a lot of grassland because, hey, that's where the flowers grow. And then we had other sites that were surrounded primarily by row crop agriculture. In North Dakota, there's not a lot of bee-friendly forage crops that are out there. There's a little bit of alfalfa, sunflower, and canola, but we're seeing rapid increases in corn and soybeans in North Dakota. So we selected apiaries across this land use gradient, and then we monitored the health of those colonies through time and also looked at population size. So I'm not going to tell you all the detailed data we collected, but basically it goes like this. If you're a beekeeper, when you truck your bees into North Dakota in late May or early June, that's when spring happens in North Dakota, they kind of look like this. They're small. And we can go into those colonies and we can assess the health and viability of the queen, look at disease, parasite loads. But we looked at colony size as well by counting the frames of bees that were occupied by adult bees. And then by the end of the season, if you're a beekeeper in the Northern Great Plains, you have the right weather conditions and you selected a good apiary location, you hope your bees look like this. A lot of honey supers, a lot of honey production, and a lot of bees in those colonies. So we assessed the colony size from here in the spring to there at the end of the summer. And then we plotted that on the y-axis. That's what you're seeing. You're seeing change in colony size through time, throughout the summer. And then when we look at the land cover around those apiaries and look at that relationship in a statistical fashion, here's what we get. We see that colonies grew less rapidly and sometimes decreased in size at sites with a lot of row crops around them. Sort of the inverse of that, sites that had a lot of grassland grew more rapidly to a larger size right here. That's very much consistent with what we predicted for our initial hypothesis. But what's more, is we followed these honeybee colonies to the almond orchards. Some 6 months later, followed these same honeybee colonies to the almond orchards, and we assessed their size again. And here's what we have plotted on the y-axis, almond frames of bees. And then the x-axis is the amount of row crop agriculture where those bees spent the summer. So we're kind of looking at a residual land use effect. And you can see the data are messy. I mean, the beekeepers have been spending 6 months in doing management, supplemental feeding their bees to bring them sort of up to snuff for pollinating the almond crop in California. And we still see this residual land use effect, where bees are smaller out here with a lot of row crop than they are over here. We estimated across the gradient about 2 frames of bees difference available for almond pollination. So that might not seem like a lot, but if we start to look at the economics associated with that, that's about $4,000 difference in revenue per apiary for a beekeeper in pollination service payments and colony splits, because big colonies equal more payment if you're in the almond orchard. You want lots of bees there to pollinate almonds. And also, large colonies can be split into multiple small colonies to make up for winter losses. And if you're a beekeeper that manages about 10,000 honeybee colonies, We estimate that this difference across the land use grading is about $800,000. So we're talking real economics here. So why does the Northern Great Plains matter where virtually no human being wants to live, especially during the winter? Well, right here, this is I think the linkage where we're seeing land use in the Northern Great Plains have an effect on an ecosystem service elsewhere in the country. That's why a person living in New York, for example, that would never set foot in the Northern Great Plains might want to care about the well-being of that landscape. And I think I have enough time. Am I doing okay on time? We're going to a break. I only have 15 more minutes, don't worry. No, I just want to finish up with my last slide here to highlight a recently developed decision support tool my team developed. We call it the Pollinator Library. This is a website of plant-pollinator interactions. You can do search features, queried searches by insect name, common name or scientific. You can search by plant species, you can search by land use type, and you can search by state. And all the data are downloadable free of charge. My team puts all of our field data up on this website, and we have a number of other contributors to the Pollinator Library. But we designed it with land managers in mind so that they can use it to figure out what plants are bees using as forage plants, and they can use that to design more cost-effective seeding mixes. Currently, we have about 27,000 observations up on this website, most of those being contributed from collaborators and gleaned from the literature. If you are a researcher and you have data you'd like to contribute, we're getting ready to launch the next version of the website. Right now, it kind of operates like a government website. It's a little bit slow, but we have optimized that and we're improving the searchability. And so we're getting ready to launch that second version. So if you'd like to be a part of that enterprise, please let me know. That's it. Thank you for your time.